Let's solve question 1D in this video. So question 1, part D, we have ln of a times x plus 1 divided by a to the power of x, derivative with respect to x. So if we differentiate with respect to x, let's just write it here as an index. We're differentiating with respect to x. And whenever you have more variables, like for instance a and x in this case, it's wise to write what are we differentiating with respect to. Is it with respect to x or is it with respect to a? Because the results will change depending on which is the variable of interest. Or you might have x and y. Again, what are we differentiating? Are we differentiating with respect to x or with respect to y? Always keep this in mind, and it's wise to write it as an index so we can remember ourselves what we're doing and we can follow through the exercise easier. So we're differentiating with respect to x. We're having a division. Well, we're going to use our quotient rule. So let's use our quotient rule. We have the first term, ln of a times x plus 1 derivative times a to the power of x minus ln of a times x plus 1 times a to the power of x derivative divided by a to the power of x to the power of 2. Alright, let's keep going. What is ln of a times x plus 1 derivative? Well, that will be ln of a times x, ln of a times x derivative plus 1 derivative, which is just 0. That's from the first term, multiplied with the second term, with a times x, minus ln of a times x plus 1 times a to the power of x derivative. Well, remember, that's just a to the power of x times ln of a divided by a to the power of x squared, a to the power of x to the power 2. Alright, what is ln of a times x derivative? Well, that will be our product rule. So we have ln of a derivative times x plus ln of a times x derivative. All of this multiplied with a to the power of x minus, here we have ln of a times x plus 1 times a to the power of x times ln of a divided by a to the power of x to the power of 2. Alright, let's keep going. What is ln of a derivative times x? Well, ln of a is a constant. A constant derivative is 0. 0 times x is just 0, so this will be 0. And here we have ln of a times x derivative. That's just ln of a times 1. So we have ln of a times a to the power of x, a to the power of x, minus, ln of a times a to the power of x, minus, and here we have, let's write a to the power of x times ln of a multiplied with this bracket, which is ln of a times x plus 1 divided by a to the power of x squared. Okay, let's keep going. What do we have here as a common factor? Because we can see ln of a times a to the power of x, and here we can also see ln of a times a to the power of x. So if we take it as a common factor, we would have a to the power of x times ln of a, and in brackets we're left with 1 from the first term minus ln of a times x plus 1. So let's keep this in this bracket, ln of a times x plus 1 divided by a to the power of x squared. Alright, now let's open the bracket here. We have a to the power of x times ln of a times ln of a, and here we have 1 minus ln of a times x, but then the negative sign affects this plus in the bracket and makes it into a minus. So we have 1 minus ln of a times x minus 1 again, divided by a to the power of x squared. Okay, now we have a to the power of x here, a to the power of x to the power 2 here, so one of them can cancel out. A to the power of x goes away with a to the power of x from here, and we're left with ln of a times 1 minus 1 goes away, 1 minus 1 is just 0, times minus ln of a times x divided by a to the power of x. A to the power of x. What is ln of a times minus ln of a? That's minus ln of a squared. So we have minus ln of a squared times x divided by a to the power of x. And that's it. That's the final answer. We are done.